C'est parti? Allez, allez. Take a chair, take a chair. No? Okay. Ladies and gentlemen. On y va? Okay, thank you. In our industry, connectivity and reliability are no longer optional. They are vital. Today, we must make different generations of infrastructure work together, from the historical coaxial network to intelligent IP system. To highlight the strengths and diversity of PowerEOC initiative, I have the privilege of welcoming 3 partners who represent the technology's excellence in development, manufacturing, and real-world operation. First, Mustapha Kermoune from the RATP group, who brings the perspective of a major infrastructure operator, managing complex, large-scale networks where reliability, safety, and maintenance are non-negotiable. Then, Thierry Fernandez from Lea Networks, an active manufacturer of intelligent Ethernet switching and communication system, driving innovation in connectivity, interoperability, and network performance. And finally, Jêrome Lopez of ADALTRA, a leading manufacturer of cable, coaxial, and connector, providing the physical backbone that ensure PowerEOC robustness, range, and field reliability. Together, these partners embody the island's international ambition, uniting industrial players from Europe, Asia, North America, and worldwide, to build an open, standardized ecosystem where PowerEOC becomes a universal between energy and data coaxial infrastructure. In many ways, coaxial technology shares a destiny similar to that nuclear power. Once considered obsolete, even discredited, it is now regaining technical and operational relevance that few had anticipated. Like nuclear energy, coax is not returning out of nostalgia, but because its efficiency and industrial logic. The revival is part of broader movement, the reconciliation between heritage and innovation. In a world that moves fast, it's tempting to discard the old in favor of the new, but our duty as engineer, industrialist, and decision maker is also to value what already exists to make it more efficient, safer, and more sustainable. In this spirit that we create the PowerEOC Alliance, an open alliance bringing together manufacturer, integrator, energy provider, and public stakeholders, with a common goal to standardize and promote Power Ethernet over coax technology. Our mission is clear: foster interoperability, standardization, while reusing existing infrastructure to transport both power and IP data in reliable, secure, and manner. PowerEOC is not only a solution to modernize the existing, and it's also a forward-looking technology, perfectly suited for new deployment, especially for like over 100 meters, where traditional Ethernet cabling reaches limits. And we are not stopping there. PowerEOC Association is currently leading complementarity work in twisted pair technology, which should soon result in an ATSC standardization process. This is a strong signal. Our technology is no longer an alternative. It's becoming a new standard supported by the European technical community. PowerEOC represents the meeting point between the past and the future of networks, a technology of transition and convergence addressing the challenge of resilience, cybersecurity, energy, efficiency, and predictive maintenance. Already deployed in sensitive scenes, RATP, Air France, Dassault Aviation, confined environment and area required high continuity, it demonstrates that we can go further, do more, and do it better using what we already hear. Within the PowerEOC Association, we are convinced that collaboration is the key. Together, by sharing our expertise and our vision, we can build infrastructure that are modern, resilient, and economically responsible. Today, here, I invite all stakeholders in nuclear, energy, and telecommunication to join us and take a part of our alliance. Thank you.
Thank you, Marc. Thank you for the introduction. I will go a little bit more into technical and what PowerEOC actually is on the physical layer. So indeed, PowerEOC has a lot to do with reuse of existing cable, and especially in the field of video protection. So here you see the traditional topology for video protection with typically a point-to-point architecture, one camera one end, the encoder the other end, or a star topology. With PowerEOC, we will allow much more flexible topologies, architectures, and most important, we'll be able to add a lot of camera, which is really needed, reserved by law, or simply to enhance the security and the monitoring of sensitive sites. So keep in mind that PowerEOC is both for reuse and evolution of the coax cable topologies, most of the time originally deployed for video protection. So how do we make this possible? So here on this slide, on the top, you have the very traditional setup of video protection with the analog camera, with its local AC power, an analog cable, so typical 75 ohm coax cable, and at the other end you have the encoder, and then you enter the IP network. With PowerEOC technology, what we do is on the bottom part of the slide. So we reuse the existing coax cable, whatever the length of this coax cable, it can be up to 2 kilometers. And with this existing cable, at the camera side, we replace the old analog camera with an IP camera. By the way, most of the analog cameras that have been deployed a couple of decades ago needs to be replaced. Simply they are aging. And second, the quality of the images which is needed now to really implement video protection requires to move to newer IP camera. So the IP camera, it's connected and powered via a standard PoE connection. PoE is Ethernet plus power on the same Cat5 cable or Cat6 cable. And we just had a small adapter. That's in this case, that's a DIN rail adapter. It can be collocated with the camera within the housing of the camera, so that's pretty easy for the installer to deploy. Again, we keep the existing cable. At the other end, we have another adapter, which connects as well with PoE. So we call these guys the TX because this is where the video is sent. We call these guys the RX. But at the end of the day, most important, the power comes from the PoE switch here, all along the coax cable, whatever the length, and the data can flow both in both directions. Of course, in case of video protection, that's mostly upstream, I mean from TX to RX to get the camera. But this can be also deployed, and my colleagues will come back on this later, for Wi-Fi access point, for example, in which case the communication is in both directions. So I mentioned this technology enables a very flexible topology. So here, a basic example, we have just replaced the analog setup with the analog camera and encoder with an IP camera on the PoE switch. So from here, we can easily add additional cameras. The second camera can be collocated with this one just to have a different angle of view, or be remote by a few hundreds of meters. We can go on adding cameras. Typically, as a rule of thumb, we consider that 4 cameras on the same coax is a reasonable strategy. And one thing that enables the PowerEOC technology as well is to create loops. Most of the time in networks we don't like loops, but with the PowerEOC technology, that's not a problem to create a loop. You just connect all these different devices with a basic BNC T, you know, the small T you use with coax cable. You add as many as you want, and if you create loops, you add very natively redundancy to the network. So if anybody cuts the cable anywhere, you keep the connectivity with your camera or any devices which is on the PowerEOC. And of course, you can do this as many times as you want. Not only the sky is the limit, but also the number of ports you have on the Ethernet switch. What I mean is that in the typical topology, this was an encoder, and encoder was a pretty expensive and a bit bulky unit. Here, you just have a very standard PoE switch that will connect your camera, power your camera, and provide all the management that your IT guys will require in terms of VLAN, security, and so on. So now I leave the mic to Mustapha, who will introduce some real-life use cases.
Thank you, Thierry. Yes, in this case, we made different topologies, as Thierry said. Long reach, of course, has 500 meters and more. For me, in RATP, we made different. We want to remove and reuse all our cables, old cables, to migrate analog to IP over coax, and as the depot also, we made different situations as this to replace analog to IP over coax camera.
Yeah, maybe Mustapha, you could introduce the setup of RATP, which is to some extent similar to nuclear power plant. In this, that you have a lot of cables in tunnels that are, you have very strong exploitation conditions that you cannot easily replace the cable with fiber or whatever, and yes. And you have loop lengths that are.
The first camera was installed in RATP since 1959. The first link. So we have many cables, of course, around 14,000 analog camera to migrate to IP. So as a nuclear situation, long range, old cable, and we can reuse it, of course. And we want to use a standard, 8C standard. That's the reason why we want to make interoperability, of course. So we have different brand manufacturers, as Thierry's company, like Lea, and we have all this information in our website from the islands. And of course, camera manufacturers. Another example. You can DC chain as the topology. You can have this example. It depends the power supply, of course, and your data budget. And last year in ADALTRA office, we made a very nice test. We plugged a 4K camera, 4K camera, 8K camera also, at 2 kilometers. Data and power, of course, and it was a great news.
Yeah, you see, this is what we have here. So the ADALTRA Logistics Center is a huge logistic platform. So that's good for us. And ADALTRA, as a cable manufacturer, has a lot of cables available. So we have the opportunity to test you can see here with many different vendors, vendors of cameras, vendors of PowerEOC adapters, with different lengths. As I said before, the typical use is 4 cameras per coax. Here we use five cameras just to push a bit the technology. And what you see here, and I think Jérôme, you come back on this later, is that even with this, you still have some power available on the cable. Means that you inject 90 watt, you power the 5 cameras, and you still have some energy left in your budget. So what we see is that most of the cables that has been deployed for video surveillance in sensitive seats, even if it was for analog, was pretty good quality cables, which makes this kind of test case that we did here in ADALTRA. We can really deploy this in real life, and again, Jérôme has some data about it.
Next point.
Thank you, Mustapha. Now I have the difficult mission to resume the benefits of the PoEC alliance. The PowerEOC technology can pretty long distance of up to 2 kilometers. When we compare with the LAN cable, the distance maximum is 100 meters only. But the limit for us is the DC resistance of cable. Now, I have 3 good news for you. First, you can use the old cable, generation cable. But you can take a camera at 500 meters. And we use a new generation of cable, upgrade just to 1,000 kilometers. The last news is on our database of Alliance. We have create a database with many cables of coaxial cable. We have integrated all the system, all the resistance, all the distance for study the installation. And we have created in our laboratory a labo test and platform. We have integrated many cables for testing your installation. And on this side, we have a different, the best of the alliance. Long reach, power overclock up to 19.5 watts, new installation, reuse of existing coax cable, migration to SD analog to 4K IP camera, energy management, daisy chaining, LAN extension, high-speed data transmission, very you sure the 8C standard, interoperability, and all the products are certified by LAN Park.
Yeah, if you allow, Jérôme, just to emphasize on the fact that it's really good for reuse and also for brand new deployment. Maybe we can talk about the Air France case. I don't know, Marc. As an example of a new deployment using coax cable, Air France. So Air France is not in the nuclear power, but they also have constraints of length, because when you have the plane park, it's a huge distance just to fit the size of the plane, and they wanted to deploy a good Wi-Fi network, so a complete coverage for their Wi-Fi for all their tech field on ground. And to do that, they deployed a brand new coax cable, and they were able to cover distances of 2 kilometers, having half a dozen of Wi-Fi access points on this cable. So it was very easy to daisy chain like this Wi-Fi access point on brand new coax cable. And just to highlight the fact that there are many cases where we go direct for fiber or this kind of thing, but the reuse is of course where we are from, and it's there are still tons of analog camera to replace with IP camera, and really we have a technology that allows to do it very cost effectively and very simply, even when the cable is difficult to access or to replace because of the environment. But also that's a technology that really makes a lot of sense for new deployment.
And this slide, we compare the table. We compare the different characteristics, as explained by Marc in intro. Optical fiber is good for the long distance, but LAN cable it's low, and coaxial cable up to 2 kilometers. The cost of installation, connective, LAN cable okay, coaxial cable is very perfect. And the extension is the coaxial is very interesting for the long distance. This customer has used this power technology RATP, Dassault, Air France, UGC, industrial, Navy, voilà, hotel. And this one is very. You can see a demonstrator on the stand, both M282. And if you have a question, you can listen.
Yeah, on the booth we have products from half a dozen of different vendors, all working together. So different cameras, different adapters, video decoder.
Wi-Fi connection,
yeah.
100 kilometers, 100 kilometers.
Yeah, we mentioned the database of cable. You can see here different lengths of different type of cables, and that's very important when you want to deploy the technology on existing infrastructure. We have now an accurate way to predict how much the existing cable can carry in terms of power, in terms of data, so that you can know in advance whether you will be able to fit 4 or 5 cameras instead of the existing analog camera, and how much power will be available, for example, for a PTZ camera, so a motorized camera, or different kind of thermal camera, LiDAR. Of course, here we focus on the video surveillance because that's easy to explain and to demonstrate. Now there are plenty of IPs that can be used. Whether I mentioned access point, but also on the booth there is a LiDAR, there is different kind of cameras. So our booth is just 100 meters this direction, M82. And here on this slide, we have displayed some.
The interoperability is very important.
Yeah, the interoperability. And interoperability is granted by a standard, and it's verified by an interop test lab. So LAN Park is a test lab which is dedicated to certify PowerEOC products. Means that all the products with the PowerEOC logo have passed a number of tests, are fit in a given category of power and bitrate, so that with this characterization of the cables one side, with the characterization certification of the products the other side, you are sure, given an existing infrastructure, how much you can upgrade in terms of number of cameras and on power available. Thank you.
Thank you.